Miss,
Yes.
mi internet está muy lento. Creo que ya lo cortaron.
Lo siento.
Pero ¿me puede decir qué podemos hacer ahorita para hacer algo en mi teléfono o así? ¿Me puede explicar qué vamos a hacer?
Ok. Está bien.
¿Y el examen lo puedo hacer mañana?
El examen es para hoy, pero no es, necesita completar de viernes.
Lo puedo hacer mañana porque ahorita mi internet está muy mal.
Wait, what? Can you say that again?
Espérame. Lo voy a escribir.
Okay. Sí, Alex.
Ok, Miss, ¿me puedo ir?
Sí.
Ok, bye.
Adiós.
La veo mañana.
All right, in about 20 seconds, we're going to come back to the Google Meet to do a few problems together. So in about 20 seconds. All right, guys, back to the Google. Oh. Cool, I've been making some announcements, and I'm glad that I was muted for that. All right, guys. Nothing, just 10 minutes is up. All right, guys, come on back to the Google Meet. I just was announcing that multiple times, and then I didn't realize that I was muted. All right, guys, welcome back to the Google Meet. All right, so we are going to do a few problems together, some examples. If you would like to do these examples with us, and then that way you can put them on your one-pager, and you don't have to do extra work by finding your own examples. We're going to do 1, 2, 3, 4, 4-ish, 4-ish problems together. And then you'll have time to, if you want to update your one-pager after that, you can, or if you need to finish it, and then you'll have time to take your test. If you are doing a digital one-pager, these are hard to type out. If you're on a Google Doc, you can hit the insert equation. If you're on a PowerPoint, you can't do that, or a Google Slides. But what you can do is if you need to take quick screenshots or screen grabs of the work that we have on our Google Meet here to put in, you can do that. Just make sure you're adding your own part to it as well. So if you're going to do a screenshot or a screen grab onto your digital one-pager, make sure you're adding a comment on it or putting in a circle or something that shows that you're doing something with that. Okay? All right. So for our first one, we're going to do some adding. So this one's adding polynomials.
And this one might be especially important to kind of do with us right now because it's been so long since we did any adding problems. Our last 3 lessons all focused on multiplying. So you kind of forgot when you're looking at this what you actually do to add or subtract. Make sure you write this one down with the steps.
All right, so for our first step, we're going to put like terms together. And when we put them together, we're going to either put it together with a plus or with a minus. It just depends on the problem. In this problem, when we look at these two polynomials, we have 3x squared plus 2x minus 9 plus 6x squared minus 3x plus 11. So we have this plus sign that's directly in the middle. And so that tells us that when we put our like terms together, we want to put that adding sign in between them. So who can name can somebody name some of the like terms they see? Which parts can go with what?
X to the second plus 6x to the second.
Perfect. And those are like terms because they have both an x, but they also have the same exponent. They're both x squareds or x to the seconds. Awesome. So I'm going to group those together. I'm going to do 3x squared plus 6x squared. And I'm just going to go through and list all the other ones that are like terms. So what else can I put together?
2x and 3x.
Good.
Negative 3x.
Good. 2x and then a negative 3x. That negative is really important that we include that as part of that 3. So we're going to have 2x plus negative 3x. I still like putting that plus sign in the middle since that's where that plus is coming from. And then also we have this negative 9 that can be paired with that 11. Does anyone remember, what do we call those numbers with no variables?
Constants.
Yeah, good, constants. So negative 9 plus 11. Big part with that is just as you pull those out, make sure you're pulling out if it's a minus, pull out that negative with it. So step 2 is now, depending on the problem, we're going to add, we might subtract, or just an overall word for adding and subtracting is combine. So add, subtract, combine. And when we do that, we're looking at the coefficients, or the numbers in front of the variables. Or we could be doing it with the constants too, I suppose. So for this first one, we have 3x squared plus 6x squared. So we're going to add the 3 plus 6. So 3 plus 6 is 9. Now this is the part that we have to remember. When we add like terms, the variable part stays the same. So it's going to stay 9x squared. Well, the 9 didn't stay, but the x squared did. All right, and then we have 2x plus negative 3x. So I'm thinking 2 plus negative 3. And if at this point you need to use a calculator to help you with that adding and subtracting, that is okay. Please do that. We would love for you to get that right answer with doing that. So 2 plus negative 3. We are going to subtract because they're different signs. So 3 minus 2 is 1. And then we have more negatives. So negative 1x. And we could just write that as negative x also. And then for our last one, we have negative 9 plus 11. Again, they're different signs, so we can subtract. 11 minus 9 is 2. And this time we have more positive, so it's going to stay a positive 2. So after we did that, our last step with these ones is to then write it in standard form. Remember that standard form is looking at the most with the exponent to the least. And then we have that minus 1x, and we can write that as a plus negative x. We could sneak in a 1 there, but usually we like to kind of hide that. And then we have that 2, and it's a positive 2, so we're going to say plus 2. And that would be our final answer. Yeah, Trent, let me know if you need to reach out to someone, okay? I'll check in with you in just a second, okay? So I'll send you a message. Check your Schoology messages in about 20 minutes. All right, so our next one is subtracting polynomials. So if you need to write this down or take a quick screen grab, give you about 20 more seconds to write that down, and then we're going to move on. All right, so for subtracting polynomials, we're going to follow that same kind of process. So I'm going to keep my steps over here. But this time when we do that pairing of those like terms, when we put those like terms together, we're going to put a subtracting in the middle, because this time we have this first polynomial minus the second polynomial. So we have that minus in between. So when we put those like terms together, we're going to want to make sure we put that minus between them. So we're looking for like terms. So do we have, what like terms do you see?
Well, 3x4 and 6x minus 6x4.
Good. So we have those x to the 4th. So 3x to the 4th minus 6x to the 4th. I noticed you skipped that first one, that 2x to the 5th. Does 2x to the 5th have any like terms?
No, miss.
No. So we're going to just keep it there for now, but we need to remember at the end that needs to be included down at the bottom. And I wrote 5 there. That was supposed to be, whoops. My brain was moving too fast. That was supposed to be a 4. Okay, what other like terms do we see?
-2x minus 9x2.
Good, we got those squared. So negative 2x squared. And again, we need to put that minus between them. So minus 9x. And then I see I have this minus 5. So what can I put together with that minus 5, that negative 5?
+4.
Yeah, that negative 4. So when I first write it, I might write it as negative 5 minus negative 4. And then I might realize, okay, when I need that subtracting a negative, we could change it to adding a positive. And again, on this one, we have that extra. We have this 3x that's just like chilling by itself. There's no other x terms where it's just x. So again, we're just going to keep our eye out for that at the end. We need to include that in our final answer. So our next step would be to go through and find our answers. And again, if you need to use a calculator to help you combine these, that would be okay. So 3 minus 6, negative 3, and then we keep that x to the 4th power. Negative 2 minus 9, so this tells us to start at negative 2 and then go backwards 9. We'd end up at negative 11, x squared. And then on this last one, we have negative 5 minus negative 4. So if you want to rewrite that, we could write it as negative 5 plus, and then instead of negative 4, we would use that positive 4. And that would get us at negative 1. So then our last step would be to write it in standard form. So when I write it in standard form, I want to look for that highest exponent, the most in the exponent position. And in this case, I see a no exponent. Here I have just an x squared, x to the 4th, and I have this x to the 5th. So I'm going to start with that 2x to the 5th where we didn't combine that with anything. That was just chilling out front. After x to the 5th, I'm going to work my way to x to the 4th. So I just kind of work my way down those exponents, 5, 4, 3, 2, 1. And with that 4, I have this negative 3. I could write that as a plus negative 3x to the 4th, or I can write it as a minus 3x to the 4th. I don't see any x to the 3rds, so we're skipping that one. We're just going to go to x squared. So negative 11x squared. And then this is the part that's kind of tricky. You have to remember that we still had that 3x. Now this 3x looks like it's positive because it says a plus there. But we have to remember out front of this one was that minus. So it's really a minus 3x. And then lastly, we have that negative 1. So that would be our final answer in that standard form. Just double checking, it goes 5, 4, 2, x, no x's. So we're good to go. All right, we have one more that we're gonna go through all the way, really talk about. And then we're gonna just quickly touch on just one problem that we talked about last week. Just make sure you know how to start it. All right, so for multiplying polynomials, we are going to ask you questions about both the area model and the distributive property. So if you've gotten really used to one and you kind of forgot about the other because you just haven't been doing it in the practice, this would be a really good one to write down, especially of the other one. But on your one-pager rubric, we do want to see at least steps written out for both or an example for both, something where we can see that you have both somewhere in there. So description of what area method means or distributive. All right, I'm going to kind of break my page down in half here, and I'm going to do distributive on the left, and then I'm going to do area on the right. And I'm going to start with distributive, mainly because I know lots of you were really great at area last week. Many of you that did your practice work chose to do area. So I'm going to start with distributive because that might be a little less, what's the word? Familiar. What was the word? So just going over that. So first thing I would do is write that out, 7x minus 9 and 2x plus 4. So the first step I'm going to do, and you might want to write it differently depending on how you think of it. Even if I'm not writing it down, I visually draw my arrows. And those arrows tell me how to distribute. So I'm going to draw them from the 7x, pew, to that 2x, 7x, pew, to the 4. So they come from the 7x to the second binomial, the second part with 2 parts. But then it's also going to start at this negative 9. So we're going to start at negative 9 to 2x, pew, pew, and negative 9 to 4. Step 2 is going to be to write out and multiply. And here we have those 4 arrows, so we know we're going to have 4 multiplication parts. So I'm going to start with that 7x times the second part, 2x. That was my first arrow there. Pew. And my second arrow, 7x to 4. Then I'm going to start at my negative 9. So negative 9 times 2x. And then negative 9 times 4. And we're actually going to multiply each of those out. So if I have 7x times 2x, 7 times 2 is 14. And then we have x and x, so there's 2 x's there. So how would I write that in my answer showing that there's going to be 2 x's?
X times x, x squared.
And then here we have 7 times 4. So 7 times 4 gives us that 28. And this time we have just that x. So just that x stays with that. Just 1. Then we have negative 9 times 2. Negative 18. And that x stays with that. And it's just 1 x in that multiplication problem. And then this last one we have negative 9 times 4. And that would give us negative 36. So at this point in step number 3, we could write it out all in order, or if you want to jump, we could combine like terms. So some of you are getting really good at just being able to look at those 4 and saying, okay, which ones are we going to put together? So we have 4 parts here. Which ones can we write together? Or which ones can we combine?
If we didn't even want to write them all down, what are our like terms? What 2 could we put together?
Sounds good, John.
And negative 18x.
Awesome. Thanks, Ahmed. So 28x and that negative 18x. So if we don't even want to write them all down, we can just combine like terms right away. So what's 28 minus 18?
Okay.
Yeah. So then we have 10x. And since we're subtracting, we're just going to keep that as that x. It's not an x squared. So now when we write it in standard form, we can just use that 10x. We don't have to use both numbers.
Now remember, Ms. Sawyer talked about this a lot last week. The really great thing about the area model and distributive is that they end up being the same answer. So at some point, if you are doing distributive, if the question's asking you to do distributive and you're like, I'm not sure if I'm doing this right, you can always check it with your area model. okay, or vice versa. All right, so for area model, the first thing that you would want to do is you want to set up like the box. I don't know what a better word is for that other than set up the box. Okay, and there's two ways to do this. Miss Sawyer always, I notice, she looks and she says, okay, I have a binomial times a binomial. So she actually breaks up the inside first. I always write the parts first and then break them up. But she knows we have two parts here, so she'll draw a line down the middle, and there'll be two parts here. Right? That's kind of how you do it, right? No?
Yeah.
I don't know. All right. And the big thing with this when we do this is that the 7x minus 9 has to stick together, and the 7x minus 9 would have to go together across the top, or it could go together down the front, as long as that 7x and that 9 stick together. Okay, so I'm going to put them across the top. Just picked it. You could do it the other way and you'd end up with the same answer, which means my blue is going to go down the side here. So this is still part of setting up my box. I'm labeling that outside part. So 7x, and then a negative 9. So that minus turns into that negative. And then 2x plus 4. Okay, then our step 2 would be that we need to multiply the boxes. So I'm going to do this in two colors. If you're not used to using the area model, if you've been like solely distributive, this might be really helpful for you to write down the two different parts. So in this first box, we're going to do this 7x. We're going to multiply it by this 4. When I move over to this next one, now I'm underneath that negative 9. So in this top row, we're going to do 2x times negative 9. Or we could write it as negative 9 times 2x, same thing. And then this bottom row, we're in that 4 row, but we're still under that negative 9. So normally we wouldn't take time to write those out. But if you're somebody who hasn't done the area model a lot, that might be helpful for you to know those multiplication parts. So 7 times 2 is 14. And then we have x times x, so x and x, that's 2 x's, so x squared. Then from the top here, we'd have 7x and 4, so 7 times 4 is 28. We just have that x. In this corner, we have that negative 9 and that 2. So 2 times negative 9 is negative 18. And we just have that x there. And then lastly, we have that 4 times negative 9, which is negative 36. Now remember about that area model that's really cool is that along that diagonal is going to be our like terms. So if you follow the diagonals, you'll see those like terms together. So now we're going to write them out with our like terms next to each other. And we're really at the same step now as our distributive property. So we have 14x squared, and I'm going to write out those green ones, 28x. And you could write them in either order. You could have done that negative 18 or that 28 plus negative 18x plus negative 36. Or you could write minus. Hey guys, I forgot the negative over here. Good double checking. All right, so we have that 28x and negative 18x. And again, that will give us that 10x. So this was really good. This helped me actually double check my answer because I realized the first time I forgot that negative with that 36. I wrote it here, but I forgot to write it in my answer. So our last step there is just to write it in standard form after we combine those like terms. My board's starting to lag a little bit.
We're almost done.
Got one little problem left. All right, so for our last problem here, we're going to go over just the idea of what we talked about a little bit last week. Oh, real quick. This one, when you see a trinomial, on your test, you're going to be able to choose if you want to use the area model or the distributive for this problem. It won't be this problem exactly, but problems similar to this. Okay. We're going to ask you to type your work in as best as you can. If you can't type in your work because it's too complicated to figure it all out or it's just too hard, you can let us know and we can bring you into a pull-out room and we can look at your work if you write it on paper. Or if you want to take a picture of your paper and send it to us in Schoology as a message, we'll look at that and put that in as your grade. All right, last one. Promise. This one.
So this was the last lesson we worked on. And we're really not going to work out the whole thing. We're just going to talk about how you want to start this problem. So these are the problems when you have the parentheses and then you have the exponent outside the parentheses. So that whole thing, that binomial, 6x minus 3, we're going to take to the second power. So what would our first step be? How would we write this out?
Rewrite again.
We write it again. Very good. So we would actually write that 2 times. So 6x minus 3 times 6x minus 3. And then you'd solve it just the way you want to solve any binomial. You can choose distributive, you can choose area, that's up to you. It's a binomial times a binomial now. Okay? So we're not going to work through this whole thing because we just did one like it. And we want you guys to have lots of time on your test. On your test, there are a few problems where it will say specifically to show your work. So make sure on those problems that you show your work. And remember, the problem might be worth 3 points, and it might be like 2 points for your work and 1 point for the correct answer. So showing your work, even if you make a mistake, is better than not showing your work at all. There are some questions specifically about distributive and some about area, and then there are some where you get to choose whatever you want to do to solve it. Okay? Remember on